In this KORNCAST, we're going to use the quadratic formula. The quadratic formula is a formula used to solve quadratic equations for x given the equation is in standard form and that it's equal to 0. Please take a moment and write down the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. In example 1, we're going to solve the following equation for x. Now please notice that this equation is in standard form and that it's equal to 0. So now we need to identify what our a, our b, and our c terms are. Well, a is the coefficient multiplied to the squared term, so 3. B is the coefficient multiplied to the x term, which is 7. And c is the constant term, which in this case is a negative 6. And before I substitute into the quadratic formula, I like to square my b term now. And that's just to make sure that I don't make any mistakes with this process in the substitution. Okay, so I'm always going to start with x equals, because that's the whole point of using the quadratic formula, to solve for x. Well, negative b, so negative, my b is 7, plus or minus square root, b squared, which I've already identified as 49, minus 4 times a, which is 3, times c, which is negative 6. All over 2 times a. Now after I substitute my a, b, and c values into my quadratic formula, now it's time to use my order of operations and to simplify this equation. So x equals negative 7 plus or minus square root 49. Now my order of operations tell me I need to multiply in here first, so negative 4 times 3 is negative 12, times negative 6 is a positive 72, divided by 2 times 3, which is 6. And now I just need to continue simplifying. So again, I'm going to do my 49 plus 72. So x equals negative 7 plus or minus square root 49 plus 72 is 121 divided by 6. And now to simplify the square root of 121. Well, the square root of 121 is 11. So I get x equals negative 7 plus or minus 11 divided by 6. So now if we recall, we have a plus or minus, which means we're going to get two answers here. So let's take a look at those now. Now for the plus, so we get x equals negative 7 plus 11 over 6. Or x equals negative 7 minus 11 over 6. Now, to simplify these two equations, we get x equals, well, negative 7 plus 11 is 4, divided by 6, which, simplifying that fraction, gives us x equals 2/3. Or, well, negative 7 minus 11 is negative 18, so that gives us x equals negative 18 over 6. Well, negative 18 divided by 6 is negative 3. So, finally, we get x equals negative 3. So the solution for this equation using the quadratic formula is x equals 2/3 or x equals negative 3. In example 2, again, we're going to solve this equation for x. But please notice that it is not in standard form and it's not equal to 0. So the first thing we must do before we start to solve this is we need to add 5 to both sides. So collecting like terms gives us x squared plus 7x plus 5 is equal to 0. Now that we have that, we now need to identify our a, our b, and our c terms. Well, the coefficient multiplied to my squared term is a 1, so my a is 1. My coefficient multiplied to my x term is 7. And my constant term is a positive 5. And again, like last time, I'm going to go ahead and square my b term now. so 7 squared is 49. Now that I've identified my a, b, and c, I can now solve for x. So again, I'm going to start by writing x equals, because that's the whole point of this particular process using the quadratic formula, is to solve for x. Well, negative b, so negative 7, plus or minus square root b squared, which is 49, minus 4 times a, which is 1, times c, which is 5, all over 2 times a, which is 1. And again, to simplify this equation, I'm going to get x equals negative 7 plus or minus square root 49, negative 4 times 1, which is negative 4, times 5, which is negative 20, all over 2 times 1, which is 2. Now continuing with my simplification, 49 minus 20 is 29, so that leaves me with x equals negative 7 plus or minus the square root of 29 all over 2. And now let's bring our attention to simplifying the square root of 29. Well, you'll notice that the square root of 29 cannot be simplified any further. So this is my final answer for x. So the solutions for x squared plus 7x is equal to negative 5 is x equals negative 7 plus or minus the square root of 29 all over 2. Please recall that the plus or minus gives us two answers. X equals negative 7 plus the square root of 29 all over 2, or x equals negative 7 minus the square root of 29 over 2. Please note that this is the answer that we would like to see for the solution for this equation. However, just be aware that there are indeed two answers for this particular solution. In example 3, we're going to solve this following quadratic equation for x. Now, in order to use the quadratic formula, this equation must be in standard form and it must equal 0. So I'm going to subtract an 8x from both sides, resulting in 6x squared minus 8x plus 1 is equal to 0. Now, in order to use the quadratic formula, I must identify my a, my b, and my c terms. Well, my a term is 6, my b term is negative 8, and my c term is 1. And again, I like to go ahead and square my b term now. Well, quantity negative 8 squared is going to give me a positive 64, because negative 8 times negative 8 is going to be a positive 64. Now to substitute those values into my quadratic formula, leaving me with x equals negative b, which is the same thing as saying negative times b, so negative times negative 8, plus or minus the square root of 64, minus 4, times a, which is 6, times c, which is 1, all over 2 times a, or 2 times 6. Now please make a special note that when using the quadratic formula and you have a negative b term, like in this case a negative 8, that you must multiply the negative 8 by a negative sign here. And also make a special note that you're going to get a positive 64 inside your radical right here. Now to simplify our equation, we're left with x equals negative times negative 8 is a positive 8, plus or minus the square root, negative 4 times 6, which is negative 24, times 1, which is negative 24, leaving us with 64 minus 24, all over 2 times 6, which is 12. Now to continue simplifying, 64 minus 24 is 40, leaving us with x equals 8 plus or minus the square root of 40 all over 12. So now to simplify the square root of 40. Well, the square root of 40 is really the square root of 4 times the square root of 10, and the square root of 4 is 2, so the square root of 40 reduces to 2 root 10. So to rewrite the square root of 40 as 2 root 10, we get x equals 8 plus or minus 2 root 10 all over 12. You're probably thinking to yourself, we're done. Because we simplified the square root of 40 as 2 root 10. Well, bring your attention to the numerator of this part of our equation. Notice that 8 is divisible by 2, as well as 2 root 10 is divisible by 2. So, in order to continue simplifying this problem, we must factor a 2 out of our numerator, leaving us with x equals 2 times, well, 2 times 4 is going to give me 8, and 2 times plus or minus root 10 is going to give me plus or minus 2 root 10. And don't forget that it's all over 12. So, recalling that I factored a common term out correctly, because 2 times 4 is 8, and 2 times plus or minus root 10 is plus or minus 2 root 10, I'm now left with a fraction here, 2/12, which simplifies to 1/6. So 1 times 4 plus or minus root 10 is going to be 4 plus or minus root 10. So I get the equation x equals 4 plus or minus root 10 all over 6. So the final solution for 6x squared plus 1 is equal to 8x is x equals 4 plus or minus root 10 all over 6. And please don't forget that this solution has two answers because of the plus or minus. In example 4, we're going to solve yet one more equation for x. And notice that this equation is in standard form and it's equal to 0. So identifying the a, the b, and the c are going to be easy. The a is going to be 1, the b is going to be negative 2, and the c is going to be 4. And again, squaring my negative 2, I'm going to get b squared is equal to positive 4. Again, negative 2 times negative 2 is a positive 4. Now substituting these values into the quadratic formula, I get x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Simplifying gives me x equals, well, negative times negative 2 is a positive 2, plus or minus the square root, well, negative 4 times 1, which is negative 4, times 4, which is negative 16, resulting in 4 minus 16, all over 2 times 1, which is 2. Now, 4 minus 16 is negative 12. So I get x equals 2 plus or minus the square root of negative 12 all over 2. So now, to simplify the square root of negative 12. I know the square root of negative 12 can be rewritten as the square root of negative 1 times the square root of 4 times the square root of 3. Well, if you recall, the square root of negative 1 is I, the square root of 4 is 2, and the square root of 3 is the square root of 3. So the square root of negative 12 simplifies to 2 square root 3 times I. So now I'm going to rewrite the square root of negative 12 as 2 root 3i, giving me the equation x equals 2 plus or minus 2 root 3 times I all over 2. Now what you'll notice that in the right-hand part of our equation, we now have a complex number with an imaginary part. So we must now write our answer into complex number form. Don't confuse this with example 3 where we want to factor out a 2 and reduce the fraction. Instead, what we want to do is we want to undo the addition of fraction process here, taking the two parts of my numerator and dividing them by 2. So we would get x equals, well, 2 divided by 2, plus or minus 2 root 3 divided by 2, times I. So now, x is equal to a complex number in complex number form. So now all we have to do is simplify the real and imaginary parts, giving us x is equal to 2 divided by 2, which is 1, plus or minus 2 root 3 divided by 2, which is root 3, times I. So the solution to x squared minus 2x plus 4 is equal to 0 is x equals 1 plus or minus root 3 times I. Now please don't forget that we have two solutions for x because of the plus or minus. We get x is equal to 1 plus square root 3i, or x equals 1 minus square root 3i. Now you have all the power.